My name is Abraham Peled. I'm a psychiatrist, and I'm trying to promote brain-related etiological conceptualization of mental disorders. And today I would like to talk about mood and mood disturbances and some insights about how we can start to think about intervening therapeutically in mood disorders. So, first of all, mood is an emergent property, meaning that mood is a property of whole brain organization, and emergent property meaning that the whole is more than the sum of elements. So, one neuron, two neurons, neurotransmitters, parts of the brain do not have mood. Only the whole brain dynamics generates something that we can define as mood, or anxiety also. So now that we think this way, let's see if we have any knowledge about it from the literature. And yes, it turns out that yes, because we already know that antidepressants, for example, SSRIs, have an influence on like 60 to 70% of cortical neurons, meaning that it's a global effect that they are having. And we know today that antidepressant effect is correlated with plasticity induction, in the sense that when neurons have more spines and more dendrites and there is a generation of new neurons, neural generation, this is correlated with antidepressant effect. We know it from ECT, electroconvulsive therapy causes increase in plasticity in the sense that there is increase in synapses, dendrites, and so on. We know it from SSRI. It's a common pathway between SSRI and ECT. We know it with recently TDCS and TACS, which also increase plasticity. So we can now correlate increased plasticity with antidepressant effect or mood elevating effect. Now, this is very interesting because it gives us like a basic idea of what could help in depression, but what is the correlation? What is the relationship between increased plasticity in the brain and mood? And why should increased plasticity be the fact that helps mood? So, in order to go one step ahead and understand this, we can borrow the theoretical developments from big studies recently, especially by Carl Friston, talking about the Bayesian brain. So what is a Bayesian brain? A Bayesian statistics. The Bayesian brain is the brain that predicts what is going to happen from the environment and adapts to it. Adapting, what does that adapting mean? There are internal representations. We have seen that in previous videos, that we have a world represented as internal representations in the brain. And these internal representations are updated all the time based on the interaction with the environment. We talked about the three networks, executive network, salient network, and default mode network, and how executive network and default mode network interact among themselves and with the environment in such a way that the brain is always predicting what is going to happen and adapting to it by adapting the internal representations. So there is like a delta, a difference between what is occurring in the environment and what is represented in the brain. This delta is called sometimes free energy, and the brain tries to reduce the free energy, and by succeeding to reduce the free energy, there is a dynamic movement from less optimized to more optimized conditions, and this dynamic movement is accompanied by an emergent property of antidepressant effect. So now you can understand how increased plasticity can help in this process, because if the brain is more plastic, it's more adaptable. If it's more adaptable, it can predict and adapt to the occurrences in the environment and reduces the free energy more efficiently and faster. So by increasing plasticity, you increase adaptability. By increasing adaptability, the Bayesian brain predictions is optimized. And by doing that, the free energy is more efficiently reduced. And this reduction is generated by a more flexible, adaptable whole brain organization, which in turn generates an emergent property, which is antidepressant. Now, this looks very complicated, but it's pretty much intuitive. Let's assume that you have an internal representation that you need to succeed in an exam. You want to succeed in an exam or in an event. And let's say that you failed. Now, if you failed, the discrepancy between the internal representation and what is occurring increases. So the free energy increases. So the whole dynamics is de-optimized in the sense that it goes against the adaptability and optimization. And this movement of de-optimized dynamics generates an emergent property of frustration and of sadness and depression. Now, let's assume that you succeeded in the exam. What happens then is that the internal representation is actually optimized in the sense that the prediction is successful and the internal representation is optimized, and the whole dynamic involves a reduction of free energy. You succeeded in what you wanted, so there is no difference between the internal representation and what happened. The difference is reduced, the delta is reduced, the free energy is reduced, and the dynamics from going from higher free energy to lower free energy generates an antidepressant mood effect. So now we have covered the idea of an emergent property of mood. We explained how increased plasticity in this framework of Bayesian brain and reduced free energy is helpful to understand antidepressant effect and then also depressive effects. So now we can go to the treatment part and see that, yeah, the increase of plasticity is something that we want, we certainly want. So let's develop new technologies in order to control better the increase of plasticity. So we have the SSRIs and we have ECT, that's fine, but many times we are not succeeding, and probably we need a more controllable and more powerful plasticity induction for whole brain dynamics. So with neuromodulation, we will probably need to target an effect that will generate widespread whole brain increased plasticity. But in order to target it, we need to target the hubs, the junctions, the hubs, which have massive brain, cortical brain influence and generate massive plasticity. So by targeting these hubs, we might be able to control better the plasticity. We know the salient network. We know that the salient network has to do with adaptability, allowing the brain to move from default mode network at rest, like rest network, to activated central executive network. So these movements are controlled by subcortical, basal ganglia structures and junctions, which have massive connectivity and feedback loop connectivity with the cortex. They are probably the target, the salient network. Junctions and hubs will be probably the targets for future, more efficient, mood-controlling technologies and treatments. So I have a series of videos talking about consciousness and psychosis and personality disorders and the whole spectrum of psychiatric phenomenology. You're invited to read my papers, articles, and connections on the web at brainprofiler.online and join my Neuroanalysis website. And also we have a group of psychiatrists who are trying to promote this direction. See you in next videos.